Okay, so now let's go over the solution to this ball that's launched horizontally from the top of a cliff with initial speed 10 meters per second and travels 100 meters before hitting the ground. The question is, how high is the cliff? So let's start off with step one, and we want to get the x and y components of the velocity. I want plus y here in this direction, plus x in this direction. So we have the velocity v0 magnitude is 10 meters per second. It's completely horizontal, and so therefore it's pretty simple to just say that v0 x is equal to 10 meters per second, and v0 y is equal to 0. Now let's move on to step number 2. Okay, so the final point is determined by which direction. Is it the x direction or the y direction? Well, the problem says the ball travels a horizontal distance of 100 meters before hitting the ground. Now, the ground doesn't really help you because you don't know where you started from, so the y direction is not really telling you what delta t is, but it's telling you that you go a horizontal distance of 100 meters, so it looks like the x direction will be the one to start off with. So the final point is determined by setting x minus x0 is equal to 100 meters. So we use the x motion to find delta t. Okay. So we have x minus x0 is equal to 100 meters. And we have v0x is equal to 100, the v0x is the initial velocity, and that's 10.0 meters per second. And so we have x minus x0 is constant velocity, so it'll be the initial velocity times delta t. And we can plug in, we have 100 meters here, we have 10, the numbers work out pretty well. So therefore, delta t is equal to 10 seconds. Now we move on to step 3. We are going to take delta t is equal to 10 seconds, and we're going to look at the y motion equations. Okay. So let's see, what else do we have? We have delta t is equal to 10 seconds. We have ay is equal to negative 9.0 meters per second squared. And we have v0y, we said, was 0. Okay. So now we're going to need to figure out how high the cliff is. So if we know the displacement in the y direction, that will tell us how high the cliff is relative to the ground. So y minus y0, then we have delta t, so let's use the 1/2 ay delta t squared formula. v0y delta t. Okay, so we'll have, plugging in the numbers, we have 1/2 minus 9.8. We have 10 for the seconds for delta t, plus 0 here. And so I end up with minus 490 meters. So the displacement is minus 490 meters, and the cliff is 490 meters above ground. Okay, thanks for watching. I'll see you guys next time.